Yeah, hello everyone, and welcome to the episode number 5. And today our problem will be the KTH lexicographical string of all happy string of length n. A happy string is a string that consists only of letters of the set ABC, and s of I not equal s of I plus 1 for all values of I from 1 to s dot length minus 1. Okay, this is some example. Yeah, and here also one example 1 n equal 1 and k equal 3. So we have the C. This is explanation. The list of APC contains all happy string of length 1, and the third string is the C. Okay, this is just some examples for this problem, and we have some hints here. Generate recursively all happy string of length n. Yeah, maybe we need to. Here we can follow the backtracking for brothers and sort them in lexicographical order and return the kth string of a if it exists. Okay, so let's start with restate the problem. We need to find the kth lexicographically smallest happy string of length n and the happy string only abc with no two adjacent character the same, and we need to return an empty string if fewer than k such a string exists. So we can, starting with broad force. Yeah, this is as to establish baseline. Yeah, we can, as approach, we can starting with using backtracking to generate all the happy string of length n, and store or count string in lexicographically order, and the return is a kth string or empty if not enough strings. Think all people can do this one. And so we need to, this is already as a complex, it will be big of 3. Yeah, we can say it is 2 power n or 3 multiplied by n power n minus 1. Yeah, because first character 3 choices, and we have also each subsequent characters 2 choices cannot be the same as previous, and the space complexity we can say it is big of n. Yeah, also, yeah, not like the time, and this is you can achieve it by creating backtracking, yeah, or using the backtracking here in this approach. But I will already focus on optimized approach. We can calculate total number of happy string of length in, and yeah, we can after calculate the total number of happy string of length n, so we can say total will be bit 3 multiplied by n power 2 power 2 power n minus 1, and use this count to skip branches for each position. We can try a b c in order, and for each candidate characters we can calculate how many happy strings start with it, and if k is larger than that count, we can skip this character and subtract count from k. Otherwise, we can choose this character and move to next position. And this is avoids generating all strings, and directly build is a kth string. And the time complexity here will be big of n, because at each position we do constant work and space complexity big of n. So I think this is already medium problem. Yeah, and we can start now to solve this problem. So we can start with calculate total number of happy string of length n. So we have total will be equal 3, and we can iterate over from and I equal 1 and I less than n and plus I. This is for calculate total numbers. So total multiply equal to. Okay, then I will check if k greater than this total. I will return this is not enough string, so I will return empty. Okay, and then he can start with create a string result as an empty string, and vector. Yeah, yes, vector of character, vector vector of characters. We can say it has the characters. That is for to store this character to represent as a happy APC as mentioned here. This is APC, and then can character for previous is the 0. Then we can iterate for and I equal 0 and I less than n and plus plus I. After that we can number of happy string for remaining position. Okay, so I can do this can count equal 1 and yeah iterate again for and j equal I plus 1 as well. Already take a step j less than n and plus plus j. Yes, we can do something here again. Yeah, inside this one I will count multiply equal to okay, and then I will iterate over the characters character char c, sorry, char c over the chart, and I will check c equal previous. I will skip same as previous character, so I will continue, and then I will check if k greater than count. So I will minus k minus count. Here I will skip this branch, and then else I will add the result plus equals choose this character, and then previous will be equal c, and I will break. Okay, then after that I will return the results. Return the results at this time. Yes, this one. We have mistakes in semicolon. We have one cases error. Let's check it. Yes, I get these errors. This is we need to less than not greater. Okay, let me debug on it. Yeah, let's check together. First one here, it is the total happy string. Total happy string start with 3 for first characters, and we have this one. I need for each subsequent character has two choices, not same as previous. And here if k greater than total, we will return empty. If k is larger than total string, I will return empty. Then this is result string to build. Then this is allowed characters APC, and this is previous character initialized to 0, no previous, and so on. And inside the loop, yeah, this isn't count 1. This is for count of happy strings for remaining positions. Okay, and yeah, for integer equal I plus 1. This one I plus 1 j less than n j plus plus. Yeah, this is inside it. I will each position has two choices except first. Okay, so count multiply by equal to, and then over the characters I will check if c equal previous, I will continue, and if k greater than, or return it again, return, yeah, if k equal a greater than count, I will already skip this branch and reduce k. And for this else, I will result plus equal c and the previous equal c and break. Okay, and then I will return the results. I'm trying to catch my scenario k3. Yeah, this is scenario why it is dropped. Let's try again. Yeah, same. Let me check. Yes, I got it here already. The problem in the already the k, if k greater than count, k minus equal count, I set it with count directly. So in the correct version here, when k greater than count, I subtract count from k minus equal 1. In the my last version, sorry, yeah, I might have mistakenly assigned k equal to count, handled it incorrectly, which breaks the logic. Also, this is already version ensure to break the inner loop immediately after choosing a character, preventing multiple characters from being abandoned. So the calculation of count for remaining positions and the check if k greater than total, also this one. Yeah, the determinants are consistent in both versions, old and the new one. And yeah, I think here, yeah, that's done now. Let's stop it. Yeah, I think until now it should go good. Yeah. And we can also discuss now the alternative approach. Let's thinking about the alternative approach to solving this problem again. And I can thinking about we can using backtracking with pruning, generate happy string in lexicographical order, and keep track of how many string have been generated, and stop once you reach the kth string, and use pruning to skip branches that cannot contain the kth string. And we can also using the DFS with memoization. This is recursively built string character by character. Use memoization to store counts of valid string from each straight. And yeah, we can use these counts to decide which branch to explore. And yeah, similar to the counting method. Yeah, I think you can also thinking about using bitmask or dynamic programming to count a valid string and then reconstruct the kth string. Yeah, and I'm thinking to ready to establish or start also the yeah playlist for explaining the backtracking, graphs, recursion, and some advanced topics like tree graph and so on. Yeah, and I think that's all of my side. Thank you so much. See you. See you. Bye.